Okay, we're going to talk about the quadratic formula, and this is a formula that we can use to find the roots or the zeros of a quadratic equation. And we derive this formula by using the process of completing the square on a general quadratic equation, ax squared plus bx plus c. And once we solve this by completing the square, we'll have a formula, and then if we just put a, b, and c in for any quadratic equation, we'll be able to find the roots or the zeros. Now remember, these quadratic equations are all parabolas. And remember, if this is positive, it's going to be shaped like a U. If this is negative, it's going to be shaped like an N. And where it crosses the x-axis, those are the zeros or the roots, and that's what we're trying to find. When we solve these equations, set equal to 0. If you look at a little graph here, if it's shaped like a U, it could be something like this. It could graph to be something like this if A was positive. It could be shifted over. We'll talk about that later. But where it crosses the x-axis, that's when this value is 0. Now remember, this just represents the y value of all these points. In other words, each point on the graph has an x value, which is its horizontal position, and the y value, which is the vertical position, which is given by this rule, or this equation. So this is the x-coordinate here, and this is the y-coordinate, depending on whatever x is. And that's going to give you the vertical position, and when the vertical position is 0, it crosses the x-axis. The x-intercepts, we say, would be here and here, and the y value is 0, so this is equal to 0. So that's what we're really trying to do. We're finding the zeros, and sometimes called the roots of the equation, which means it's the value of x that makes the left side equal to the right side. In this case, the left side will be 0. So let's take a look at how we do this. And we're going to use our process of completing the square. So the first thing we're going to do is move this c over to the other side. So we'll have ax squared plus bx equals negative c. And remember, when we did the completing the square, we wanted to not have anything in front of the x squared except for 1, so we'll divide everything by a. And once we do that, we have a nice x squared, so we've got 1 in front of the x squared, plus b over a. X, and that equals negative c all over a. And we want to remember, take a look at this, the square root of x squared is x. Just remember the process we did when we did completing the square. And we want to take half this number and put it up here. So if we take 1/2 of b over a, we get b over 2a, so that's the number that goes up here. And we're going to square that number, and that's what we're going to add. So b over 2a times b over 2a. It's b over 2a squared, and that's going to be b squared over 4a squared. So we're going to add that to both sides. Okay? So about our b here. And now we know that we have a trinomial square here. We've actually constructed a perfect square trinomial or a trinomial square. And we know that this left side is going to factor to b. And what goes here, this is the sign. It goes here, and just these little numbers, x and b over 2a. Now on the right, we have this. Now I could reverse these, but what I'd like to do is have a common denominator, so I'll save myself a little bit of space. What's the least common denominator between these two fractions? Well, it's 4a squared, so I need a 4a in the bottom, so I have to put a 4a in the top to make this the same. And now I can do a little work over here and say this is going to be equal to negative 4ac all over 4a squared plus b squared all over 4a squared. And now when I rewrite this over here, I can put the positive term in front, so I've got b squared all over 4a squared, and I've also got negative 4ac all over 4a squared, so I can just, well, I'll write it in two terms, 4a squared, and then minus 4ac all over 4a squared, and then I can put that over one fraction, so I just kind of worked out my steps. B squared minus 4ac all over 4a squared. All right? Now I know if x plus b over 2a squared equals this, then just x plus b over 2a equals plus or minus the square root of this. All over 4a squared. And I can break this up. B squared minus 4ac all over the square root of 4a squared. So I'm going to use another step over here, so I'll say x plus b all over 2a equals, and that's going to be plus or minus now, and I can have the square root of b squared minus 4ac all over, and the square root of 4 is 2, and the square root of a squared is a, so 2a. And now I'll subtract b over 2a from both sides, so x equals negative b over 2a. If I move it to the right, it makes it negative b over 2a, plus or minus the square root of b squared minus 4ac all over 2a. And now I can put these over a common denominator. Move this up a little bit. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a, and there's your quadratic formula. So there's the quadratic formula. So that's how we derive it, and it's just completing the square. I'm sorry my work got a little bit sloppy here, but I hope you could follow everything. So again, we're just applying the process of completing the square to this general form. That's a parabola, and we're finding the zeros. That's going to find the zeros, or where it crosses the x-axis, or where its value is equal to 0. That means its vertical position. So there's your quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And you need to know that by memory. And I'll show you a few examples in the next video.